All right, so I'm Erika. Today I'll be giving an introduction to vector search. Are we all familiar with vector search, vector databases? No, okay, one. That's fine. Hopefully after this talk you will gain an understanding and understand what vector databases do and how you can perform vector search by yourself. I am a developer advocate at Weaviate, an open source vector database. You can run it 4 different ways, either Weaviate embedded, which runs natively in your application. So once you close it, it completely kills. Also Docker Kubernetes, and then also we have our managed SaaS, which is called WCS, and you can get started with a 14-day free sandbox, which is great to get started so you don't have to put your credit card down. One of the clickers to not have to go over there. Okay, so today I'll be covering what traditional search is, and then that'll lead me into what vector search is and how it is different. Then I'll give an introduction to Weaviate, not too salesy, just so you can gauge an understanding of what Weaviate is, the different directions that we can head in for search, and kind of where we are now in the retrieval augmented generation, like the LLM kind of space. And then I'll share a demo and then a Python notebook. So we have the Weaviate GitHub repository, and I created the Weaviate recipe. So it's like these really short notebooks that are written in Python and is very user-friendly, in my opinion. So I guess if you don't think so, you can share your feedback with me. All right, so starting off with traditional search. Or how do we, does anyone know how we typically find information? Kind of like what happens in the back end of Google? No. That's fine. So how the PageRank? Yeah, that is another thing as well. I guess to build on top of that, so you take your query embedding. So what is Weaviate? That is transformed into an embedding, so just a vector of numbers, and then you compare that with each embedding that is stored in your database. So you take the query and then you try to find documents that are nearest to that query embedding. So the traditional approach with this is keyword search. So I hope we have some wine lovers in here. So let's say you're looking for some white wine. You know that you want it to be white, a dry, medium, full body, and you want it to pair very well with seafood because that's what you're cooking tonight. So you're like, okay, I have an idea of what I want. It's a Chardonnay of what I'm looking for. Maybe I'm just curious about what kind of brand I want. So here you have 3 options. But what happens if you are kind of a newbie with wine and you just want a wine that pairs well with seafood? Because you don't have wine for seafood in your database, or maybe Google isn't familiar with wine for seafood, that doesn't make sense. No products are going to be found. And this is the limitation of traditional search engines. So in order to find wines that pair well with seafood, maybe Google has a list of synonyms that someone like a search relevance engineer has put together. So when you search for seafood, it knows maybe they want fish or shellfish or saltwater fish. And then that can help you find your Chardonnay that you're on the hunt for. All right, so the limitations of keyword search is the lack of understanding of context. The wine of seafood, I want a white wine. I don't want just like any other kind of wine. I'm like very specific. So there's that lack of understanding with keyword search. Then there's also the sensitivity to the word variations. What if you have a typo? You're screwed. So that's not very good. And then also it is limited to one language. So a lot of these ML models, specifically with Cohere, they are multilingual. You search in English, you can get objects back in Japanese and Spanish, etc. So that leads me on to vector search. Okay, so now again, I have my query, wine for seafood. The vector search engine is understanding my query directly, and it's saying, okay, you want this Chardonnay because it pairs well with the dinner that you're making. And how this is retrieved is because your data has this wine and a description about it, and just briefly, it just knows that it's good with fish. Notice how in the description, it doesn't have like that it's a wine or that it's a seafood. It knows that fish is seafood. So it's going to return this object. Okay, so now why vector search? I see a lot of like, oohs, ah, it is very nice in my opinion. But yeah, so why vector search? And I guess really kind of what this slide covers is not why Weaviate, but Weaviate is one option. We do have competitors out there, but that's relevant. But it just allows you to store data objects and vector embeddings together. So it stores the object along with its embeddings, so you can do that dual search. And then these embeddings are generated from ML models, and it just allows you to seamlessly search through even billions of objects. Some people come up to us and they're like, I have 10,000 objects, can I store it in Weaviate? And it's like, yeah, we pushed like 900 million objects into a database, and it is fully functional, and it's able to return the objects at a seamless pace. So one thing that I like about this visual on the right-hand side is this is a vector space. So you have your unstructured data, whether that be text, images, audio. You can also store the structured data as well if you have that. And that is converted into a vector. Weaviate doesn't handle that. You can use models from OpenAI, Cohere, Hugging Face, etc. Any model that does this, and Weaviate just handles the orchestration of that. So you pass in your OpenAI key, your Cohere key, and then Weaviate will transform your data into vectors, and then it will store it in this beautiful vector space. This is just a simple graph just for visualization purposes. Obviously with real world data, it's a bit more messy, but notice how here we have animals on the left-hand side and then fruits on the right. This is dependent on the embedding that is generated from the data, right? So on the left, we have query kitten. Just similar to the wine example, I don't have kitten in my database, but the ML model understands that kitten is a cat, just a young cat. And then also you can see that with respect to the vector space, dog is far, far away from banana because they are not similar. Okay, so again, how does this work? You take the data, you pass it to this ML model to generate the embedding, which is just a long connection of numbers. And then how does it work? So you have the ML model and it creates this vector space, and this is an index for making quick and efficient search. Then you plug in your data. So my example of wine. So my data are the pink dots, and notice how it is where the fish is, where the beer and wine, and not really with fruit. I mean, I guess you could cook dinner with fruit, but I don't know. That is just the example. So your data is plotted in the vector space, and then you're running the query. So now it's honing into this one particular spot in the vector space, and then it's able to retrieve all of the options in this circle. So you're looking for the Chardonnay, but it's going to give other ones that are maybe pretty similar. So you have like a Sauvignon Blanc in there, and notice how it's like maybe the taste, the notes are different. Do we have wine connoisseurs in here? I love wine personally, but Sauvignon Blanc is like, it's a white wine, pretty similar to Chardonnay, maybe not as buttery, but pretty similar. So even if that's returned, the objects aren't going to be bad. So then to put it, no worries. So then to put it all together, we have the vector space, you add your own data, then you have your search query, and output, you get the results. And this is all done extremely fast, and I'll jump into how that is done. So an introduction to Weaviate. So Weaviate has a custom implementation of HNSW written in Go. So this allows for efficient and quick similarity search. Vector databases use approximate nearest neighbor algorithms in order to do this kind of quick retrieval, rather than doing like a brute force method where you take the query embedding and then compare it to each object in your database, because imagine how long that would take if you have millions of objects. Yes.
I always meant to ask, so is this an algorithm that is older before embeddings came about, or it's actually an embedding algorithm, this HNSW, do you guys?
HNSW is fairly new. Connor is actually research scientist.
It's 2016, so yeah, I mean, the FI stuff that we were talking about earlier, that's a little earlier than that, like 2011.
So fairly new, and even I spoke with him about it, but like MongoDB, they're not vector database native, but they are adding this functionality because they do see the importance of it.
What does NS stand for? NSW?
Yeah, hierarchical, navigable, small world. I never fully write it out because if I have to say it, I'm gonna fumble. So I just say HNSW.
Is this a new algorithm?
From 2016. Yeah, it's like fairly recent, I feel like, in comparison.
I know from a NIPS event for image similarity to find copyright infringement, like YouTube or videos, that's an active area of research, and there are new algorithms coming out that are probably more recent than this, but for images only.
Yeah. I mean, yeah, because my example was only with text, but we can also handle images, audio, and we have like a I'm getting carried away, but you can also search with images and videos.
And this doesn't need any keys, it runs on a CPU, it doesn't need GPU, is that right?
CPU, yes. Yeah.
Nice.
And then depending on if you run it locally, then you might need like a powerful machine, or you can let us handle it with our Weaviate cloud service. But depending, if you have a powerful computer, then go for it. Yeah, so quickly what this is, it's not extremely important to the talk, but just quickly covering what HNSW is. So it creates this hierarchical graph. So it has the 3 layers. The top layer includes the query, and then layer 0 on the bottom contains all of the data. So the blue dot, the goal is to find the document that is nearest to this query vector, right? So we're going to go all the way down, traverse the graph downwards, and then the blue dot the pink dot will be returned from the blue query. And promise to get started with Weaviate, you do not touch this at all. You can configure HNSW, but you don't have to. Okay, so then recently we released HNSW and product quantization together. And what this does is it compresses the vectors, so it's great for saving memory. I believe it's a bit slower because you're going to have that trade-off, but it is more cost efficient. And for some people, it's like you have to balance the trade-off for your application.
It's slower with the quantization?
A bit slower because you're compressing it and then it saves memory. But Connor, can you explain more if you have more?
On query, or are you doing that before? You usually, it was kind of confounded by 2 things. A lot of times you would bring it back to the original representation to like resort the queue. And then also we like do it for disk and memory optimization. So is kind of confounded by, it's not like product quantization itself is slower. That's like what you were talking about with the NeurIPS competition where they hash the vectors basically with quantization. But it's like moving it from disk to memory is also kind of why this is slower.
Oh, interesting.
So then we have like the neighborhoods is what they call it, and the dot is going to represent that area. So it's like, yeah, a bit slower, but it is compressing it. All right, so Weaviate also has like a modular ecosystem, and this is really what differentiates us from our competitors. So we have Weaviate clients, so you can write this in Python, JavaScript, TypeScript, etc. But then if you have your own vectors, you can just bring your vectors to Weaviate and then store it in your instance, which is awesome because, I don't know, if you already have your embeddings, it's like, why run it again? So that's something that's awesome. And then with indexing, we have HNSW-PQ. But then with search, so we have BM25, which is keyword search. And then we have semantic search, which is vector search, so wine for seafood. And then we have hybrid, which is BM25 and semantic mashed together, which is really good because some people will say, I have this they have data that is maybe not correctly represented in these embeddings. So the key to that is the model just doesn't completely understand what your data is. So what hybrid is doing is using BM25 and semantic together, and the weighting of it is dependent on the alpha parameter. So if you set alpha to 0.5, it's weighting it both equally.
Yeah. So it's the first time I see about indexing in your database. I mean, I know with classic databases, indexing is useful, but how does it work? What's the purpose of indexing here for your use case?
Oh, so it's properly storing your data. So like the vector space, and if you like, here, why don't I just show this? So this is indexing, like the properly storing your data of like, okay, this side has beer, wine, fish, and then the other side has fruit or something. It's just like that indexing is very important for proper search. Yeah. And then for the results, you can improve it. So we have a question and answering, which is like, what is Weaviate? It will output the answer. Then you also have the generative module, which is using RAG, which I'll cover and is like extremely exciting these days. And then we have re-ranking. So we use Cohere's model to do re-ranking. So once you retrieve your objects and it's like, the results aren't great, let's re-rank the results. So you're comparing the query to the objects that came out of that answer and then re-ranking it again. So basing that query off of each object, and then maybe the fifth answer previously is now the first one because it is the most relevant. And that is a bit slower, but if accuracy is key for you, that's very important. Okay, so emerging directions in search. So I guess I covered it previously, but I wanted to cover hybrid search being a new thing that we added to Weaviate, and we also have our hybrid fusion. So I love this image. I give it to our design woman, Svetlana, and I said, I want a fire, and then dense and sparse embeddings to make it hybrid. So dense is vector search, and then sparse is just like that BM25, like 0001, like a bunch of zeros, right? And then dense is the vector search where each position has a meaning. Okay, but now moving on to like the hot new topic of retrieval augmented generation. So we've all used ChatGPT. I won't tell your employer. But if you ask ChatGPT, what is the weather today? It's going to say, I have no clue. My cutoff date was September, or it just says September 2021. It's like, well, you're useless to me because you're not up to date, or maybe you have a question on like documentation that you're trying to like build an app on, and it's like, Streamlit? I've never heard of it. Well, actually it does know about Streamlit, but like maybe not their latest features. So the solution to this is connecting the LLM to a vector database. So here we have, I'll start with step one. So you have your documents, and then you have your Weaviate database, and you have your prompt. So you're taking the filtered relevant documents from your query, passing that on to the ChatGPT API, not really including with Cohere as well. But our generative module, we do support OpenAI and their various models, I think like 2 or 3 models, and then also Cohere as well. So we're taking those relevant documents, passing it on to ChatGPT so it has that knowledge of what the weather is today or what is the newest feature in Streamlit, and then it is going to customize that response. So that's really taking it from step 1 to step 2. And it's able to basically like chat with your PDFs, chat with your PowerPoint documents. There's like a whole bunch of ETL companies like Unstructured, NumAI, Vectorflow, et cetera, that give you the option to take your PDF documents, convert that into embeddings, and then now you get to chat with it, which is really awesome.
How do you pass it to the OpenAI? Is it just the document itself? So like, if it's like a massive document, it just won't.
Yeah, well, I mean, you have...
You chunk it?
Yes, chunking is key, especially for the long documents, because there is like the rate limit that you'll hit with OpenAI, so it can't be extremely long, but some of their models do support longer context windows. I think like OpenAI has like a 16K, but some are fairly smaller. So chunking is key. And I would say, yeah, you'd have to do that beforehand, but like LlamaIndex supports that right before you're going to vectorize your data. You can specify the token limit. And then also another thing is like the rolling window. So when you hit the chunk and it ends here, you're going to want to have that overlapping window. So it has that knowledge of the past paragraph, which can then improve the results. But it's like a bit staying focused. Yeah, more time. Okay, I'm going to share what we built at Weaviate. Oh no, will this go away? There we go. Okay, so this is Verba, the golden RAG. And it's powered by Weaviate. And what this is if you ask a question, what is Weaviate? ChatGPT would have no clue. But if you ask Verba, it will point you to exactly where it specifies what Weaviate is, so it's citing its source, but then it's also generating the output in the background. So this is a cast result. My colleague Edward is extremely talented and put this together. So we also have caching in the background. So I think at some point we might hit all of the questions someone could ask. So he won't get charged anymore. But you can see that it says like Weaviate is a cloud native modular real-time database, etc. So this is like almost exactly to what I would say. I think it's still going. Yeah.
So it's streaming the response back as the tokens come in, it's just displaying them.
Yes, and right now we have it so we need to have the full response. We're not like doing it word by word, but that's something that we want to improve. This is like the first iteration of it, but we are constantly improving it. If you guys would like to contribute, it's open source. And then another cool thing that I like about this is you can use Verba on your own data. If I go to...
Is it, sorry, can
Yeah.
I just ask, is it just based on that? Is it summarizing all of the documents that are pulled out that are relevant, or is it just the one that's highlighted right there?
Yeah, so it's mashing together all of the most relevant documents,
Okay.
but this is the first source. So the distance from the query to the is the yeah, and then you can like bop around, and then you can also go to the document where it actually is referencing it, which is quite neat. But yeah, so for
I have a question.
Yeah.
Yesterday, I was trying to have a conversation with another speaker, and I didn't know the match between my background and his background, so I asked Bing Chat AI.
Oh, interesting.
So I asked, like, this is the professor's CV, and I have this particular project on chess. I'm a chess guy. So how does this match? What should I do? And he said, oh, that's the perfect professor. He does ancient board game stuff. These are his papers. And I'm like, clicking is not work. It's clicking, not working. I waited like 15, 20 minutes until the call again. I asked him, this is correct? No. So it just came up. So I didn't get the part, I missed the part that these links are real. How does this check happen? Because this hallucination is still happening, big issue. You cannot even ask a proper question. Today, at work, you said, don't tell your employer to use ChatGPT. Today, I used, and I had a meeting, and I'm looking at the link, and the link is supposed to go some AWS or Google Cloud website. No, it doesn't go there. It doesn't, I'm like, what is going on? So I'm very skeptical about this hallucination part. I just want to understand how this is not doing that.
Funny thing, it actually does hallucinate. All LLMs are going, all language models are going to hallucinate. Someone actually asked a question in our community channel and was like, is this right? Is this code right? It's not working. And you're like, yeah, sorry, it outputted the incorrect code. And this is really dependent on the RAG techniques that you use and like how you feed it into the language model. It's like LlamaIndex has done a lot of great work and they have advanced techniques to kind of like solve this issue, but it does hallucinate. This is just, it doesn't completely remove hallucination, but it just makes it context aware.
Okay, that's good, because you said you know where the reference is. Sometimes the reference is not the reference you seek. It says this is just not true. It happened multiple times.
Yeah, that's good. So these are like documents that you have in your data, right?
Yes.
I guess you can show that to some extent.
Yeah,
Right.
so
Okay.
Verba is using our documentation, our blog posts, and then eventually we will add Connor's YouTube podcast as transcripts. So it can fetch his YouTube videos, and then we can have like these conversations with the YouTube videos as well, and then also our forum as another source of information. Yeah, it does hallucinate. It is using Weaviate documentation, but if you scroll down here are the instructions.
I apologize, but
Yeah.
I just don't really know these kinds of things. So what's happening in the back is, and you give it a prompt, Weaviate finds the most relevant documents, and then it is passing that to ChatGPT as like the context, and then it passes the actual question, and that's what's showing up.
Yeah, and then I'll output the response.
And that's why the hallucination can happen in the text portion, but the reference cannot be a hallucination.
That's a good thing. That's very important.
That was a bug in your case. It was not supposed to do that.
Because I asked Bing Chat, and Bing Chat came up with fake references. That's what happened.
That was hard. Fire to like.
The link is correct. It's just that the description of the references
Right.
fake. It's hallucinating.
So in this case, you know the reference exactly because it was actually pulled out of the database. It wasn't just created by the. No, okay.
That's good.
You say that as like metadata of we know this. If people want to learn more, here's that link that you can use as a metadata from the retrieval. Like this is the information if you want to go like put that at the end of the response.
Exactly. And it would be nice to also be able to filter by the metadata. So maybe you don't want to reference the blog post because, I don't know, you just don't like it, you prefer the documentation, you can maybe filter that out as a good iteration. I'll add that to Edward's project.
And then this is probably a tangent, but like, if it's passing OpenAI, I mean, I guess I'm still stuck on the, it passing all of that information to ChatGPT and then keeping all that context. I guess what I was thinking that there are retrieval augmented generation where it's passing essentially the vector itself, like the representation of the document, not the text of the document itself.
Correct, because it's retrieving it from Weaviate. I mean, Weaviate stores the object along with its embedding, but it would pass in the embedding reference to ChatGPT, not necessarily like the whole document, and then it'd have to chunk again and go through that like whole process.
But that's not what it's doing now. It's just passing just the text.
Yeah.
But there would be a world in which you can implement it to actually take the embedding, use the embedding rather than.
No, that's what it's doing. It's passing in the embedding only, right?
Yeah, I think that.
Yeah, well, the problem is the embedding models are usually different from the latent space of the language models. So like if I try to give you the vector from the OpenAI's Ada 2 endpoint to ChatGPT, it's not in the same latent space, so I can't just put it in there. But yeah, the famous paper about that is DeepMind's retro model, where they're trying to align it so the language model and the embedding model are trained like end to end like that. And then by handing it the vector instead of just the input text, you're able to like really blow up the size of the transformer memory this way.
I see. Interesting. Okay.
Well, that's pretty cutting edge, but.
I guess it was, I don't know what I was like reading about, but I guess I was understanding that there's a way that you can take the representations from the model itself and store those as embeddings and pass that as the input to the model, right? And then they're aligned, right? And they're getting essentially the same.
Well, you
Crazy.
usually embedding models are like pretty small models because as Erika mentioned, you do like 1 billion inferences.
Yeah.
So like, I remember one time when the Hugging Face had that Bloom language model, they're like, we're gonna encode it with it, and it's like it's gonna take you forever because you're doing like 1 billion predict. Like how much you pay for your ChatGPT. If you were to do 1 billion of those.
Yeah. Okay. Yeah, that makes sense.
Always be careful when software has your credit card. Which is another thing to note with Verba is you do have to connect it to OpenAI. I mean, with us hosting it, it is free to use. But if you want to use it on your custom data and import your own data, then you obviously have to pass in your own key. So that's Verba. I guess another quick thing then I can.
Is it just with OpenAI then? With the OpenAI API, you can't use it?
Currently, yes, but we do want to add Hugging Face transformers as well, so it's free to use and you don't have to add your credit card, which I know some people are like a bit skeptical about.
And you can host it internal.
Yes.
That'd be
Is there anything with like Llama?
Oh, yeah.
That's another one as well, yeah. Kind of want to support all the models because, especially with your application, I think like there are some preferences.
I have another use case, like I write grants, right? So, and the token size is usually, the grant instructions are sometimes very large and they are out of the scope of the memory, so it forgets. How can this be used for such use case? I have a PDF, let's say, like I have a PDF with a lot of instruction that I will summarize to the bare minimum of what the grant is about, and I want to start writing ask questions to the LLM and get answers.
Yeah, so I can share about that, but that is definitely doable with these different, and I just wanted to share that it does output code. So if you go home and you're like, I want to go through the Weaviate documentation, but I have a question, you can ask in our community Slack, you can ask in our forum, but then maybe Verba has the answer, which is quite handy. So yes, these are the Weaviate recipes that I'm very proud of. But here we have generative search, which is doing that retrieval augmented generation. So it's creating those answers. Then we have hybrid search. And then we also have similarity search or text to vec, which is pure vector search. But then we have various integrations as well. And I think what you would be most interested in is if you have you used LlamaIndex before? Because it has LlamaIndex. It's an LLM framework. So they handle like the chunking, the like orchestration of getting you that answer from your PDF. Yeah, I guess that's the best way of writing it.
They come with a similarity search database. That's your functionality. Right?
Yes. So yeah, you definitely still need, they call it a vector store, and Weaviate is a part of it. And that's just important for, like the database side of it. They do have great query engines as well. So it's like a little bit more, it is more advanced than like the vector search, the hybrid search. But if you want to do pure vector search, which is sometimes enough, then you can just use Weaviate solely. Okay, one example. I can't remember which one it is, so I am sorry. But basically, LlamaIndex has Llama Hub, and this is where they have a whole bunch of different data loaders. So you have like PDFs, PowerPoints, and you can use unstructured, which is great. So like this one, I'm reading in all of the data that is hosted on this URL. So you can chat with this document. Okay, sorry. This one does not have PDFs, but essentially we just use the
Links
PDF
okay.
reader.
Many PDFs are also exist on the web, in the Grant website. So it's HTTPS things also.
So yeah, you can pass in URLs, PowerPoints, documents, all of that jazz.
So what's a bit confusing to me is that there's a bunch of projects like LlamaIndex, other similar ones, and they have overlapping functionality. And sometimes they sit on top of each other, like you'd use Weaviate on top of LlamaIndex. But you could use LangChain on top of this and that. And it's sometimes hard to figure out which one should you pick, what's the best choice, depending on what you do.
I don't think I'm allowed to give that answer. But essentially, yeah, LlamaIndex and LangChain, they are doing the same thing. It's a great market right now, so everyone wants like a piece of the pie. Right now, I'm making tutorials on LlamaIndex, so I'm going to be more biased, but LangChain is also doing great things as well.
So should I think of LlamaIndex as an ingestion tool, like the parsing piece, the chunking piece? That's what it's for?
Yeah, so you can extract the data, so from the PDFs, the websites, then they also handle the chunking, so they have like, they call it nodes. So taking your PDF document and making it into smaller chunks, and then it's going to vectorize that, store it in your vector database by using this vector store, and then you create this query engine. And yeah, I won't share that.
Some PDFs are really long, so it's just not possible. When you write the grant, they're like 50-page grant, and then there's questions related to this PDF. You have to search PDF different location, and you expect the answer from that location. It's difficult. It becomes difficult to answer every question by one by one.
And LlamaIndex also has different indexes as well. So they have like the they have a hierarchical kind of index where it stores like the top node will be the full document, but then each node or each chunk is like related to each. And this is great for like summarization, because what if you want like one page, summarize that, and then you need to properly store it, and then that would probably make it.
And where do they do the summarization in this case?
I mean, it could, yes, with the query engine that you use would depend. They have like various query engines. They also have like if you ask a very complex question that I think in like data science world is called multi-hop. It'll break down like what is ref2vec and Weaviate. It needs to understand what ref2vec is, and then also what is Weaviate. And then it comes together and combines the responses to make one simple response that is coherent using the response synthesizer, which is like a whole other thing that you can also configure for your application.
And Weaviate sits as the vector store in this sort of model that you're describing. Okay.
But then if just vector search and like generative search is enough for you, then you don't necessarily need to use LlamaIndex. It's kind of remind like this fancy like query engine and all of this.
But
Ask more questions.
there's also like to train to actually do the embedding. Weaviate doesn't create.
We do handle that. We handle the orchestration. You just pass in your OpenAI key, and then we'll pass it on to OpenAI, and then OpenAI will return those embeddings, and we'll store it in Weaviate in your vector class.
Oh, okay.
And then you can also have.
So you need that, but it doesn't have to be OpenAI. It could be whatever.
We have Cohere. We have Hugging Face as well.
Gotcha.
Okay, so that was a bit about the demo. I didn't go in order. So yeah, that was my talk. I hope I'm not.
No.
can I ask, because it's at the end now, maybe it's a bit more time. So your database is a graph database. And LlamaIndex can parse these documents and create a graph of the chunks, maybe, the way they're related. So how do you take advantage of the graph structure in your database? Because that's something that you have and other similarity search databases don't have, actually.
Well, I guess with the graph structure, there's like, for one, we were talking earlier about recommendation systems, and like one thing we do is you'd have like user is one class, and class are like collections or tables, like that's our abstraction for like, table. And so it'd be like user liked product, and so we would average the three, say you like 3 products, and we'd average those 3 vectors, represent the user to then search with the user, and that's a pretty good way to get like a really easy recommendation. That's mostly what we use the graph for. One idea is you search in one index, and this index links to another index, which is a bit confusing. But it'd be like if you have like a structured table within a Wikipedia page. So you're like billionaires on Wikipedia, and then there's like a table, and then you want to do like an SQL style query, because we also do have like most of it's not like the super advanced SQL style indexing, but if you want to just take like the average age of billionaires, you could do that also in Weaviate, so you can like link indexes that way. But mostly with the graph structure, like we can do just like filtered vector search, like the blog, like if you want to search blog posts or documentation, and I would probably advise that before I'd start separating the classes, because also the biggest benefit of the technology is like scaling the approximate nearest neighbor. Yeah. So I don't really recommend splitting it into multiple tables.
Okay, I see.
Very cool. Other questions? We still have a few minutes. Well, technically we have all the time in the world.
Share. This is the website, and this is where we have the documentation. So we're at PyData, so I'm assuming everyone prefers Python. So this is the installation and setup. So essentially the steps are to connect your Weaviate instance, define your schema. So how should the data be stored? So you have your class, and then you have your properties, that metadata. You upload it to your Weaviate instance, and then boom, you're searching. I guess in the recipes, I can share.
How's like, this is a kind of a weird question, not a well-formulated question. How small is this? Could you just have this on like a bunch of little, like, could a person have their own little like Weaviate instance like running in some small container or something like that? Yeah, separated out or something like that.
Create a Docker container, and you just map to a subfolder on your laptop or something, and then you can just run it for like.
I guess is it small enough to be able to like do that like feasibly? Like, is it, that's the.
I haven't run into any problems, but then again, my data hasn't like exceeded maybe like 10,000 objects. Here's a hybrid.
Because that's a really interesting thought, because like I do scientific research, so I have like a whole bunch of papers that I've never read.
Yeah, me too.
So this is like a very useful way to find those documents if you can do the correct vector space.
But the trick would be maybe the documents have some like tables or figures or things. So, and only the text portion might go well through this.
So they just published, or was it Google or Facebook just published NumFOCUS, which is specifically for extracting information from scientific articles.
Really?
So that's like another reason this was like top of mind.
Oh, okay. What's the name of that? Maybe
NumFOCUS.
Nougat.
NouGAT.
I see.
That's right. It's been trending on GitHub as far as I know.
Yeah, like it's the images and stuff, the multimodal.
I haven't been able to play with it.
Okay.
Yet.
That's what I don't know.
Sorry. I can also share. Thanks for letting me use your laptop.
This is great.
I mean, it's because I didn't set up the Wi-Fi for.
So under Weaviate tutorials, I have this how to address PDFs using unstructured.io, which we've partnered with in the past. And actually the notebook is using 2 research papers. Because unstructured has uses the latest OCR models and has different ways of indexing or like parsing through the PDF documents that handle tables, specifically in images. So here is Connor's paper. So how unstructured does it? I mean, I'm not super familiar with unstructured, but for this demo purpose, what it's doing is it's creating an element from it, and then it will partition it so you can see that it's taking out the abstract, the intro, the background, every subheading that is in the research paper, doing some other stuff, whatever, it doesn't matter. But essentially at the end, and then this is where you are connecting to your Weaviate instance. So Weaviate embedded is one way to run it, where it'll just run in your application, but once you close out of it, you'll have to do everything all over again. So just keep that in mind, defining the schema. So I have my class document, which is that one research paper, and then the source is the text. And then also, for some reason, we were storing the abstract as well separately. Okay, moving on to the end is just where we ask questions. And I think this was an older example, but you can see that we are running a BM25 query, and I'm curious about papers about house prices. So it's able to extract the document that is talking about this, and we labeled it as paper 2. But again, it could output the title to be a bit more specific, and then you could reference it as like your source. And then here we have the generative module. So this is the prompt. I'm asking it to summarize the paper, and the abstract is it's taking the abstract from the paper that it's retrieving and then generating a summary. So this is exactly what you're looking for. And yeah, so just get like a quick summary about the first paper and then the second paper as well. And then there were a few limitations that we ran into, but unstructured raised a lot of money recently, so they're just getting better. This is one way to do that.
Unstructured, is that free?
Yes, it is free.
Keep that in mind.
And then if you just want to use LlamaIndex, there's the Llama Hub. So unstructured has, there we go. Unstructured is here. So see, you can pass in text documents, PowerPoints, JPEG, all of that.
So LlamaIndex is on top of unstructured. They don't do their own parsing.
No, so unstructured was added to LlamaIndex. Because even Weaviate is on here. So if you already have your Weaviate instance running and you don't want to go through the process of vectorizing and storing it in the index, you can use the Weaviate loader. And that is an option to just connect LlamaIndex to your existing Weaviate instance. So, and then I have that in the recipes as well, just to give people a few options. So, yeah, do that.
Pretty cool.
Exciting times.
Thank you so much.
Yeah, thank you.
Yeah.